one yesterday, I just didn't get to it. So we were graphing these polynomials, and in order to graph them, they had to be factored first. So what could we do to factor this one? Do this with x minus 4. So then I kind of ask you a series of questions. So the first one, what's our degree? 3, the highest power. Second thing, the end behavior. So if it's an x cubed, we know it looks like the chair. So the ends go opposite directions, down, up. What would cause that to flip? Negative. Okay, third, any zeros. What would make x squared equal 0? 0, but because it's a square, multiplicity of 2. What makes x minus 4 0? 4. Okay, does the graph cross or bounce? So at 0 it will bounce. Yep. And at 4 it will. Okay. Then we did the y-intercept. So that's when you plug in 0 for all of your x's, and we get 0. Okay, so we know it's going to start down here and end up here. It's the x-axis at 0 and 4. Y-axis at 0. So start here. At 0, our graph will bounce. It's going to come down, come back, and hit here, and it goes through. So it should look like that. Make sure the only place you're touching your axes are those points that we marked. Can't cross anywhere else. It's also a curve, so it shouldn't look like a zigzag or anything like that. It's a nice smooth curve. Is that one okay? So 31, we have 1 over 25, to the 2x plus 1, equals 125 to the x minus 4. The easiest way to solve exponential problems is if we can get a common base. What would my common base be? 5. So 1 over 25 would be 5 to the, and 125 would be 5 to the, power to a power, what do we do with our exponents? We distribute that all the way through. Then, if we have the same base on each side, what can we do? So if I subtract over my 3x, negative 7x, add my 2, divide, and we get 10 over 7. You can always check those by plugging them back. Is that one okay? Let's do 2. Go back. There are 2 different ways of doing this. Did anyone just look at log base 6 of 36 and say what that equals? What is log base 6 of 36? 2. It means 6 to what power equals 36? So you could do that. Probably the easiest option. And you get negative 1/5. If you didn't though, so let's say you didn't recognize it or it couldn't be solved like that, we can always take our logs and turn them into exponentials. So it's 6 to the 5x plus 3 equals 36. Get a common base, 36 is 6 squared, and we get to the same point. 5x plus 3 equals 2. So 5x is negative 1, and x is negative 1/5. So 2 options for how we might get there. Either one is fine. You should also make sure any log problem you do have to verify at the end that both the base and the argument are positive. Here it didn't matter because the variable wasn't in the base or argument, but you need to be checking that. On 33, I can't just look at this one and simplify it. So we do have to use the definition, change it in exponential. So 2 to the 5th equals 4x plus 1. 2 to the 5th is 32. Subtract your 1. Divide by 4, so we get 31 over 4. This one you do need to check. All you really have to verify when you check is that if I plug this in, do I get a positive number? If not, it would be a no solution. This one, we're okay because you get log base 2 of 32. So that works. Are we remembering this log stuff? 34. If these logs are subtracted, how do we put them together? So you write the log in front and you divide the arguments. X plus 7 over 3. Now if you have a log on each side, what do you do? So now we have to plus 7 equals 21x plus 3. This was actually an exact question off the test, and I would say almost half of you missed it because of a very basic mistake at the end. So if you bring the 4, or subtract your 3 over, subtract your x, I cannot count how many of you said x equals 5 at the end of this question when it was on the test. When you divide by 20, it was 1/5. I don't know why I remember that so many people missed that one, but it stuck out. Yeah, a lot of people missed. Just got in a hurry there. Check your answer if we plug in 1/5. 1/5 plus 7 is positive, 3 is positive. 7 times 1/5 plus 1 is positive, so it's okay. The natural log of x plus 3 plus the natural log of x plus 1 equals the natural log of 3. If two logs are added, how do you put them together? So we have to FOIL, so that's x squared plus 4x plus 3. Now we have a log on each side. Drop the log. So at this point, you can factor out an x. So if you solve, you get x equals 0 and -4. But what do we have to do? So if you put in 0, 0 plus 3 is positive, 0 plus 1 is positive. So that's good. But if I put in a -4, -4 plus 3 is -1. We can't do the log of a negative. So 0 is the only answer that works on this one. Can we get a common base? No. So if common base isn't an option, what do we do? So you add a log on each side. And how does this help? Property of logs, exponents come down in front. So So if I'm trying to solve for x, it's multiplied by the 3 and the log 4. So we're just going to divide by both of those. So my suggestion, when you do the calculator for these, I would probably use that fraction button so you can see it and make sure you're typing it in correctly. Every time you push a log, it opens a parenthesis, so you have to make sure and close that parenthesis. I want everybody to type this in, because we've had a lot of issues with typing these in and getting the correct answer. Sure. This is like the total of victims. This is the total of offenders that were in this series. So vertical, you have the offenders. Horizontal is giving us the victims. So there were 7,205 altogether. But we can look like when the victim was less than 18, but the offender was at least 18. Does that make sense?
Yeah.
You're welcome.
So wait. So the offender total would be that one.
This is the grand total.
Okay.
What was the question that you're
It was at least 18.
the offender being?
Yeah.
Let's see. Yeah, so it'd be like that.
Okay. Thank you.
Okay, so when we type this in, we get 0.4308. Did everyone get that? 37, graphing a log. Okay, so what we always did is set these equal to y and rewrote it as an exponential. So this means 4 to the y power equals x. To graph exponentials, we always did a t-chart and we put in -1, 0, and 1 for the exponent. The exponent is my y. So then my x, 4 to the -1 is 1, 4. 4 to the 0 is 1. 4 to the first is 4. So 1/4, -1, 1, 0, 4, 1. Where's your asymptote at? Right. You have a vertical asymptote at 0. Because you'll never do 4 to a power and get a negative answer. And so our graph looks like this. On the final, I would be looking, do you have your asymptote in the right spot? Do you have your points marked? Domain or range? What is the domain from this graph? And we do a parenthesis on 0 because it's not equal to range. What y's do we hit? Is that okay? Let's talk about our systems. Okay, our strategy is to take 2 equations at a time and get rid of a variable. So if I wanted to take the first 2, what could we get rid of? Y. Yeah, you could get rid of x or y here. Probably easiest just to get rid of the y because we don't even have to do anything. If I add those, I get 6x minus c equals 5. Okay, I have not yet used the third equation, so I have to use it and the one I just got to eliminate a variable. So what do you want to get rid of? x. So we would take this one times negative 3. So it gives me negative 6x plus 9z equals negative 6. This one's 6x minus z equals 5. If we add those together, positive and negative 6x are gone. 9z minus z is 8z equals negative 1. Divide, and z is negative 1/8. Once you have one of your variables, you can work backwards to get the others. So if I wanted to plug it in right here, 6x minus z, so minus negative would make plus 1/8 equals 5. We subtract that 1/8. Divide by 6. We get 13/16. You guys with me so far? Now I have x and z. We just need y, so you can go to any of the equations. I'll just go to the second one. So that was x plus y equals 5. So if we subtract the 13/16, so then we write it alphabetical order. X, Y, Z. Problem number 40. We did not do great on this on the test. Either you knew what you were doing or you didn't. There was really no in between. So let's talk about this. It's really just a matter of remembering what the strategy is, because when we did the homework, everyone did fine. First, we have to make sure we can multiply them. To do that, we do the size. Remember, size is row by column. So this one is 2 rows and 2 columns. This one is 2 rows and 3 columns. If these numbers match, we can multiply. So we can multiply. This tells me my final answer will be 2 by 3. So 2 rows, 3 columns. Okay, to get those, you take a row times a column. Okay, so I'm going to do the 5 times 3 and the 5 times 2. So 5 times 3 is 15 plus 5 times 2 is 10. And then you keep going. You're going to do the first row times the second column. So 5 times -5 and 5 times 6. So 5 times -5 is -25 plus 5 times 6 is 30. First row, third column. 5 times 1 is 5, 5 times 1 is 5. So 5 plus 5. Then we move to the second row. Second row, first column. So -6 times 3 is -18. 4 times 2 is 8. Second row, second column. -6 times -5 is 30. 4 times 6 is 24. And finally, second row, third column. -6 times 1 is -6. 4 times 1 is 4. So if we simplify, that gives me a 25, 5, 10 for the first row, -10, 54, -2 for the second row. Is that okay? 41 is asking us to graph a system of inequalities. X squared minus 4. What does that graph look like? It's a parabola that's been moved down 4. When in doubt, you can always plug in points. 0 squared 0 minus 4 is -4. If you put in a 1, 1 minus 4 is -3. If you put in a 2, 2 squared minus 4 is 0. Same thing for the negative. So it's this parabola. How do we know if it's solid or dashed? So we look at the inequality. If it's not an equal to, it's a dash. So because we didn't have an equal to, we have a dashed line here. To decide your shading, pick a test point. So 0, 0 is a good one. Then that gives me 0 is greater than -4. Is 0 bigger than -4? Yes. So we tested 0, 0, it worked. So we are shading inside here right now. That's not my final answer yet, so don't get too crazy with your shading. Then to graph this one, this is just a line. Y-intercept -2, slope is 1. Up 1, over 1. Solid or dashed? We know that because it has an equal to. You can do the test point here. You get 0 is less than -2. Is 0 less than -2? No, so it tells you shade the other side. You could also look at it and say less than means below. So I'm shading down here. So your overlap region is this section, below the line but inside our parabola. So I should be able to clearly see both graphs and tell the darkened part where your overlap was. Are there any other questions on the study guide that I have not answered? Okay, so factoring, the top you can't really do much. What do you do at the bottom? X minus 3, x plus 2. How do you find an x-intercept? Put in 0 for your y. Which then when you multiply over the bottom, it's really just when the top of the fraction is 0. And when you solve that, what do you get? 0. So we hit the x-axis at 0. How do you find a y-intercept? And we get 0. So x and y-intercept are both 0 here. Vertical asymptote. How do you find those? Okay, and you have to give me the equation. So what would they be? Vertical is up and down. X equals, we graph those as dashed lines. +3 and -2. Okay, horizontal or oblique. We talked about this yesterday and we said it's really just like a division problem. If you take 2x squared divided by x squared, what do you get? 2. So it's a horizontal y equals 2. Okay, then we picked test points to help us finish this graph. So we need something on each side of these vertical asymptotes in order to graph it. So for instance, if we put in -3, okay, so that would be 2 times 9, so 18 over 9. Oh, 9 minus negative 3, so 9 plus 3 is 12, minus 6 is 6, and we get 3. So negative 3, 3. That's all I really need to see. I'm above that horizontal asymptote. And you can certainly use your calculator to plug that in. You don't have to show all that work. So we get a section right here. When you draw this, it should be a curve that is getting closer to your asymptotes. The middle section, you could plug in some points if you wanted to be sure. If you put in a negative 1, you would get 2 over, so we're getting a negative. You put in positive 1, you get a negative, so it's going to, both ends are going down and approaching our vertical asymptotes. And then we need to put in something on this side. So if we put in a 4, so that's 2 over 16 minus 4 minus 6. And so we see that also turns out to be above our asymptote. So those test points are just to decide if it is above or below that horizontal asymptote. And you have to do each section so that we get our graph. Is that one okay? If I had given us, let's say, would this have a horizontal or an oblique? Oblique. When you go to divide, x squared divided by x, you're getting something with an x in it. How do you find an oblique asymptote? So we have x minus 2, so we have x squared plus 4x minus 1. Okay, so you divide the first terms. X squared divided by x, you multiply. X times x is x squared, x times negative 2 is negative 2x. Then what do we do? X squared negative x squared drop, 4x and 2x, 6x minus 1. 6x divided by x? Okay, and that's all we need. You don't have to finish it. So it's just y equals x plus 6. Y equals mx plus b. Is that one okay? Okay, let me give you a matrix multiplication problem. Make sure we remember those. If there's something specific you guys want, just tell me. I'm just trying to make up things here that we might need. What if I told you to multiply? What's the size of the first one? And the second one? So can we multiply them? Yes. How big will the answer be? 3 by 2. 3 rows, 2 columns. Okay. So you take the first row times the first column. So 2 times 1, 1 times 2, negative 3 times negative 8. First row, second column. So 2 times negative 6, 1 times 0, negative 3 times 6. You guys with me so far? Now I'm doing the second row. So second row, first column. So 4 times 1, 0 times 2, 2 times negative 8. Second row, second column. So 4 times negative 6, 0 times 0, 2 times 3. Then third row, first column. So if we get 5 plus negative 2 plus 16. Third row, second column, negative 30 plus 0 minus 6. Do we get that? Does everyone know where I got my numbers? Final problem of the day, unless you guys come up with something else. Let's do this problem. If I ask you to find all the possible zeros, what do we have to do? P's and Q's. Where do we look to get our P's and Q's? The P's come from the constant. So everything that goes into 9 would be plus and minus 1. And Q is leading coefficient, so that's plus and minus 1 and 2. So possible. Okay, now find all zeros. What do? Plug them in and find one that works. And how do we know it works? It equals 0. All right. You guys let me know when you find one. 1/2 works? Okay. So once we find one that works, we do synthetic division. And we have to do that because if all we're doing is plugging in all these numbers, we will miss any answers that are irrational or imaginary or repeated. So we have to do the division. 2 comes down, 2 times 1/2 is 1, 12, 12 times 1/2 is 6, 18, 9, this gives me 2x squared plus 12x plus 18.
Good afternoon, Monroe City High School. This week, JUCO is selling Candy Grams. You can purchase one for $1 today through Thursday during lunch. Send a Candy Gram to a teacher or to a friend. They will be handed out during first hour on Friday. JUCO dress-up days this week are: tomorrow, wear red and green; Thursday, wear your ugliest Christmas sweater; Friday, wear Christmas pajamas. Friday is the Christmas party. There will be dodgeball, volleyball, bingo, and snacks. You may also bring your own board games or video games. During lunch, there will be ice cream for the junior class for bringing the most cans in the canned food drive. Seniors, please check your emails. The yearbook class needs you to fill out the senior superlative and your senior quote. Thank you for your help. Band and choir are selling carolgrams for $5 to addresses within the walkable Monroe City limits. They are only selling 50 carols this year. For more information, email or see Mrs. Layton or Miss Bartholomew. Art Club members are reminded to pay